Hello guys, welcome back to my channel. We now move on to question number 5 on May-June 2022 CXC Mathematics past paper. Let's get right into it. Question 5. A school nurse records the height 8 cm of each of 150 students in a class A who were vaccinated. The table below shows the information. Alright, so we have the height here. As you can see, we have it in a range between 60 and 80. Alright. And then we have the number of students. Now notice that this says that the height is greater than 60 but less than or equal to 80. So it can be 80. Very important to note. Alright, let's take this down. It says complete the table below using the information to calculate an estimate of the mean height of students, giving your answer correct to one decimal place. Okay. Alright, so we're going to complete this table here. Now, one thing we should notice is that we have the number of students here, which is my frequency, and we have the midpoint here, which is the midpoint of the height, and we have the frequency multiplied by x, which is the midpoint. Good. Alright, so let's complete the table. Now if you notice that I'm constantly going up by intervals of 20, and this is constant, right? So the midpoint would actually be in a sequence. Notice we go from 70 to 90. That's me adding 20. 90 plus 20 would give me 110. And 110 plus 20 would give me 130. Yeah? That's one way to do it. The next way to do it is that if I want the midpoint, I have these values here. I could go 120 plus 140. And I divide that by 2. That would also give me 130. Now this says the frequency multiplied by x, and x represents the midpoint. So that's going to be 67 multiplied by 130. Of course, your calculator will do that perfectly fine for you. So let's bring up the calculator. So let me delete this. So that's 67 multiplied by 130. That's 8,710, right? 8,710, and that goes there. Now remember why we're doing this. We're completing the table so that we can find the mean, right? And we know that the mean, which is x bar, is equal to the sum of fx, which means the sum of the frequency multiplied by x. Let me take out this bracket here so we don't get this mixed up. So it's the sum of the frequency multiplied by the midpoint all over the sum of the frequency. Alright, let's see. So x bar equal, which means I'm going to have to add up all of these values here. And I'm just going to put the total, and I'm going to add up the total number of students, which we don't have to do because they told us it was 150. Alright, so there are certain things that we don't have to do. But let's bring in the calculator to do the addition here. So let me clear all of this. Alright, so I have 280. Then I have 1,800. Then we have 3,850. 3,850. Then we have 8,710. And then we have 3,000. And then we have 680. In total, that's 18,320, right? 18,320. And I'm going to have to divide that by 150. So the smart thing to do is to not clear the calculator, because you have that already. Just go divide by 150. And that's 122.1. Alright, correct to one decimal place. So 122.1, and that is in centimeters. So that is my mean height, or my average height, means the same thing. On my next page, it says in class B, the mean height of the students is 123.5 centimeters and the standard deviation is 29.87. For class A, the standard deviation is 21.38. So let's go back. Alright, we found the mean to be 122.1. And of course, for me to understand this data, let me go previous, I need to go back up and look at what the data represents again. Alright? Always bear that in mind. So technically, this data represents a height of 150 students. So that is recorded by a school nurse who was vaccinated. All right, let's go. It says, using information provided and your response in part A, comment on the distribution of the height of the students in both class A and class B. So for class A, the mean was 122.1 and my standard deviation here is 21.38. Now what does the standard deviation represent? The standard deviation represents the spread, how the other values spread with respect to the mean. Now with a smaller standard deviation, it means that the mean is more representative of the data values. So technically, this is telling me that the spread of the height with regards to the mean height is smaller for class A. So let me put that in. So the spread of the heights for class A is smaller with respect to the mean, alright? With respect to the mean, as the standard deviation is smaller. So the smaller standard deviation, the smaller the spread, which means that the mean value is more representative. So the mean here is more representative of the data given for class A than the mean for class B, which has a larger standard deviation of 29.87. So you can actually explain all of that and you get your easy 1 point. All right, let's take this down and see if we have a next question on this page. All right, so that was the last question on that page. We go to the next page, which says complete the cumulative frequency table below and use it to construct the cumulative frequency curve on the grid provided. All right, cumulative frequency. Now this is pretty much very easy. What we do to get the cumulative frequency is that as we go along, we add, as it suggests, cumulative, right? So we go 4 plus 20, which gives us 24. Now I'm going to have to add 24 to 35, right? Which is going to give me 59. We add 59 to 67. And of course, if you want to verify, you want to ensure that you're doing the right thing, you have a calculator. So when I go 59 added to 67, I get 126, right? So it makes sense. Then I'm going to have to say 126 added to 20, which is going to be 146. And 146 plus 4 is 150. So pretty much that is good. It says use your cumulative frequency curve. Of course, I'm going to have to complete the graph of this. So I'm going to go to my next page to see what is on, right? Now, bear in mind that, of course, my cumulative frequency is going to be on the y-axis. And of course, let me just put this in carefully. We use the upper limit on the x-axis. So the cumulative frequency on the y-axis and the upper limit on the x-axis. So let me just put x here. So let's go to the curve. Now I'm going to reduce this because this graph is pretty large. I'm going to reduce the scaling here. All right. And let me move this over a bit. So notice that it started to put in the information for you. You have 80, which goes to 4. You have 100. So let me go back to the previous page. So we want 120 with 59. Let's see if we have that. We have 120. We don't have 59, right? So I'm going to put that in. All right, let me use red. So 120, and I'm going up to 59. Now notice that you have 5 lines in between. So if this is 50 and this is 60, it means that each line represents 2. So it means that 59 would be right in the middle right here with 120. I'll put in my letter X right there. Let me go back, previous. Next we're going to have 140 with 126. 140 with 126. That is in, so we don't have to do that. We have 160 with 146. So 160 with 146. We go all the way up 140. So each line will be 2. So it's 142, 144, 146. I'll put the X right there. Guess what? We have our cumulative frequency curve. So all I have to do at this point is to simply draw the curve, right? All right. Now, it's a bit more challenging to draw because I'm drawing this on a computer screen, but it should be pretty easy for you. You want to make one draw that captures everything. So that's 160 with 146, which was right here. Let me make sure I'm getting everything here. Right, I want my curve to be as smooth as possible, right? Right, not perfect, so I'm gonna have to fix this middle piece because I need it to be smooth. Right. Alright, so let me just get out this little part here. Let me get this out. Let me get this out. Now, whenever using a piece, if I was using a paper, it would be much easier for me to get it at one curve or one draw. Now, what you want here, I'll probably put on my title, right? Cumulative frequency curve showing. So, cumulative frequency curve showing the height of 150 students, right? Pretty much we put that in. All right, let's go back. They said using your frequency curve, find an estimate of the median height of the group of students. All right. Now the median, let me just put the information here. The median, which we can call Q2, all right, let me just put it over here. Q2, or the second quartile, is halfway. Median suggests middle, right? So it's going to be half the cumulative frequency. That's going to be the position. Let me put position of Q2, which is the median. So it would be a half of the cumulative frequency. And bear in mind that the cumulative frequency is on the y-axis, always. So a half of 150, which would be 75. Now, this is not my median. This is the position of my median. So before you can find the median, we have to find the position. Now I need to find 75 here. So look at what I'm going to do. I'm going to get my line. And I'm going to go to 75. So remember now we're going up by 2. So we have 72, 74. So 75 is right in the middle here. We go to the graph. Now once we get to the graph, we now come down to get an idea of what the median is. So all the way down. All right. Now on this arc as well, we have each line representing 2. This seems it's going to be in the middle. So I'm going to have 120, 122. Since it's in the middle, it's going to be 123. And it's an approximation. So let me go back previously. So I can say that the median, which is Q2, is approximately 123 centimeters. Now remember that this is not a perfect value. It's an estimate. So you might, depending on how you draw your curve, you might get a slightly different value. But that's okay. As long as you have your curve as smooth as possible, you're good to go. And that pretty much wraps up that question. All right, no reason we shouldn't get full marks on that. All right, let's look at question 6. The diagram below shows a solid made from a semicircular cylindrical base with a rectangular prism above it. The diameter of the cylindrical base and the width of the rectangular prism are 4 centimeters each. All right, let's bring this paper down a bit. Now, the first question says, calculate the total surface area of the solid. Now, bear in mind the surface area is what is exposed, what you can actually see. All right. Now, what I can see here is that I can definitely, let me start with the base. Down here, I can definitely see the cylinder, right? And it is semi, so it's half. So you have half of a circle around there, you have half of a circle here, and you have half the curved surface area here, as you can see. So since they gave me the formula for the cylinder, we can say that the total surface area would be half that of a cylinder, right? So it's going to be half times the total surface area of the cylinder, which they give you here, because half of it is missing, of course. It's semicircular. So it's going to be a half 2 pi r squared plus 2 pi r h. All right, plus let us talk about the cuboid that is sitting at the top. Now, of course, normally the opposite faces on a cuboid are the same, but guess what? This part is inside, so it's not considered to be a surface. That is inside, right? And in fact, even inside there is no surface because this part is open. So we're looking at the surfaces that we can touch on the outside. So you have this side, we have that side, we have the front, we have the back, and we have the top. So if we want to, what we could do is that to avoid confusion, we could call this a length. We could call this the height. And we could call this part the width. So let's look at these two sides, right? We have width and height. So we have 2 width and 2 height. And let me call it height 2 because we already have height already. And we don't want to get this confused with the cylinder. Alright, so let me call it H2. So it's going to be 2 of those are exposed as surfaces. So it's going to be 2 width height plus the front here and the back over there are also exposed. We're calling the front the length, right? And we're calling this side the height. And of course, all of these are rectangles. So we're going to have 2 length, height. And finally, since only the top is being exposed, we don't have the bottom being exposed as a surface, and we have this as being width with length, because this would be the length, it would be just be length times width. And that practically covers everything. Remember, we're calling this height 2 because we actually have height being used already in the formula. All I have to do now is to populate this. Now look at what I do. So I'm going to have a half, open bracket, 2 times, and guess what? I'm going to go to the bottom of the paper to see if they suggested what I should use pi as, because sometimes they say use pi as 22 over 7. Sometimes they say use 3.14. So it depends on what they ask you to do. Alright, let me go back up. I don't have that there. Did they tell me in the question? No, I don't have it in the question either. So it is up to me to decide what I want to do. Okay, good. Let me pull this down so you can see it. Alright, so I'm going to be using 22 over 7 as pi times the radius square. Now, notice that here is 4 centimeters, which means this is also 4 centimeters. Now, from here to here is the diameter. That's a complete thing, right? So the radius is half of that. So it's going to be 2 squared. Alright, that good. Plus 2 times pi, which is 22 over 7, times the radius, which we found to be 2. The height, this time, is the distance between the two faces. The same thing that we call length right here. So the distance, the perpendicular distance between the two faces is what you call the height. And this, in this case, is actually 12 centimeters. So times 12. That takes care of my cylinder. Alright, let me carry this down a bit now so I can get everything captured. I probably should carry this over. Alright, let's start with the rectangle. So we have 2 times the width, and of course we said the width is 4, times the height, or height 2, which in this case is also 4, which makes my life easier there, plus 2 length times height, so that's 2 times length, which is 12, times the height, which is 4, plus length times width, right? And the length, of course, is 12, and the width, of course, is 4, so times 4. Alright, so I can pull this up now because this is really going to be a matter of calculator work. Alright, so let's allow the calculator to do some work for us. Alright, so let's clear this up. We're going to take care of the cylinder first. Alright, so we're going to have a half. We're keeping that outside of the bracket. Inside, we're going to have 2 times 22 fraction bar 7 multiplied by 2 squared. So that's 2 pi r squared plus this part, which is 2 times 22 over 7 multiplied by 2 multiplied by 12 equal. We got a very nice value here that is actually equal to 88. Wow. So let me go ahead and put that in. So I'm going to have 88 here. And then I can put in all of this, right? So let me take out my calculator. I'm going to clear all of this. And I'm going to have 2 times 4 times 4 added to 2 times 12 times 4. 2 times 12 times 4 added to 12 multiplied by 4. And that is equal to 176. So I'm going to have 176 here. And then I'm just going to add both of them. Well, I have 176 in there already. So I'm just going to plus 88 equal 264 square centimeters. And that is my total surface area. Let's take this down and see if we have anything here. That's pretty much 4 marks. So you have quite a amount of time to do it. You just need to take your time and ensure that you get the questions correct, right? Alright, calculate the volume of the solid. Alright, let's go back. Let's pull this down. Now, this is something I want everyone to remember. This is a prism because it has a uniform cross section. Alright, notice it has the same face here and the same face here. So it's a uniform cross section. And anywhere along here that you cut it, the face will look the same. Whenever you have a uniform cross section, to find the volume, all you have to do is to find the volume of one face, one complete face, and multiply it by the distance between the two faces. So let me go there and set up a formula. And that makes the thing so easy. So this is it. Volume of prism equal area of cross section multiplied by the length. So I just need to find the area of the cross section. Alright, let me go back so you can see what I mean. The cross section is really this part, which turns out to be a square, because if this is 4 and this is 4, it also means that this here is 4 centimeters. And down here you have a semicircle, alright, where the diameter is 4. So pretty much everything is taken care of there. And the length here is 12. So let's go. So the area of a cross section is going to be length square for the square plus, since it's a half a circle, it's going to be a half times pi r square. And the length, as we can see, was 12, so times 12. Alright, now our length was 4, so that's 4 square plus a half times pi, which is 22 over 7, times the radius square. Remember the diameter was 4, so the radius is 2. 2 squared times 12. Once again, we can use our calculator to do a nice job here. So, open bracket, we're going to have 4 squared plus a half multiplied by 22 over 7 multiplied by 2 squared. Alright, we'll go to the end there. And of course, we close the bracket and we'll multiply by 12. So that is, let me get that again. 267.4. So that's 267.4. And this time it's cubic centimeters, right? And that is the volume. Alright, the solid is made from gold. Alright, very important here. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. Calculate the cost of gold used to make this solid. So this is the first thing. This is in cubic centimeters. They gave you the cost per gram. So you have to turn this into grams, right? But what did they tell you? 1 cubic centimeter of gold has a mass of 19.3 grams. So if that is the mass for 1 cubic centimeters, how do we get the mass for this, which is 267.4? We have to multiply, right? So I'm gonna go total mass is equal to 267.4 multiplied by 19.3. Once again, your calculator does that job nicely for you. All right. So it's going to be 267.4 multiplied by 19.3. That's 5,160.82. 5,160.82 grams. Now 1 gram of gold costs $42.62. So I'm going to say my total cost is going to be 5160.82 multiplied by $42.62. Good? Because we know the cost for 1 gram and we have 5,000 odd grams. So we just simply need to multiply. Alright, don't forget the units. Alright, I have that in there already. So I'm just going to say multiplied by 42.62. And that's 219,954 and 15 cents. So 219,954 and 15 cents. And 15 cents. And don't forget to put on the money sign, right? Now, while you do everything here, it's always important that you always remember your dollar sign. And of course, money only has 2 decimal places, so don't forget that as well. All right, very important. And that takes us to the end of questions number 6. All right, thank you for watching, and please continue to watch. Thank you.